Welcome, guys. We're going to start in about a minute. Let's just see if more people are going to join in. Superman, are you ready to take over?
All right, yeah, thanks, Martins. I don't know if we should continue now or just wait an extra 2 minutes for everybody to join in, or we can just continue from now.
I think we can start.
All right, so let me just share my screen. And please confirm if everybody can see my screen.
Not yet.
So you still can't see my screen now?
No. Okay. Yeah, it's visible now.
All right. Just a few moments for this thing to open so that I can start with the concept.
Your screen has gone dark. It's completely black for me.
So is it the same for everybody?
It's still
Anthony, what's
loading.
the status on your end?
It's in black. Yeah, I'm seeing GC screen on this phone.
Okay.
I can see it on my
Okay.
side.
You can see on your side.
Yeah, I could see it, but now it's gone. I think you
No,
removed it, but I could see it.
Okay, let me just share again. So I'm sharing now. Please confirm if you can see.
Okay, yeah. So,
Yes.
So it's fine for everybody.
yeah.
Right. Okay, if that's the case, then we can start. So the last time we had a session, we talked about, especially Martin talked about variadic functions and all the things in detail. So today is going to be a continuation from that to function pointers. So the session will be two parts. The first part theory, just short theory, and then the second part will be the coding part of the whole session. So when we talk about function pointers, they are not different from normal pointers that you know. So everybody, if you can see my handwriting or if you can't see that, just please confirm. Can everybody see my handwriting?
Yeah, I think I can see it.
Okay, fine. So when you are dealing with pointers, the thing that you know is that pointers they hold addresses. So that's the first thing which you know. So any pointer is just there to hold an address. And then a function is just a set of instructions performing a subtask. So now if you are talking about function pointers, you're talking about a pointer that holds the address of the instructions of a function. Just like you would do for normal pointers, you would have something like an integer, maybe this is integer x, and then you know this carries like 4 bytes in memory. You can find that x is somewhere in your memory, whereby if this is x, maybe x is at address 200. So now if I define an integer, I point it to an integer and then call it ptr, and then do something like this. Ptr is equivalent to the address of my x. So basically what I'm saying is that this PTR, it's a pointer which holds the address of something. In this case, it's going to be the address of an integer, all right? So the integer that I'm pointing to is x, and x points to 200. So what you get from there is that 200. So the same concept works with regards to function. So with function pointers, you have a function like just like any simple function, whereby you perform a set of operations, and then those operations they happen sequentially, or if maybe one instruction is to move to another, that would happen in that case. So you have those instructions stored somewhere in your block of memory. So like usually you have something like a heap, stack, maybe text, and then code. So if you write a function, say it resides in this section of your memory where you have code. So the instructions, all of them, they reside there. So now when you do that and you save it in your local machine, you will have that function somewhere. And then now if I wanted to point to it, I'm just going to point to the instruction. Same thing. Now the only difference between function pointers and the normal pointers is that these you cannot malloc them. That's one thing. So if you had something like x or maybe an integer pointer or a pointer to something like you would do with malloc, so that thing would use your memory space, which is under the heap section. But now when you're dealing with function pointers, a function already exists. So it's just a piece of code that resides somewhere. So now when you point to that address, you're not going to point to the address in your heap. You're not going to do that. Only mallocked things can stay in the heap section. But what you're going to do in that case for function pointers is going to point to the instruction. So it's going to be the entry point, the first instruction of your function. So that is the whole difference between function pointers and also normal pointers that you know. Is everybody fine with that? If you are content with what I'm saying, just please confirm so that we can move to a different
Yes,
section.
so
Okay,
far.
so this is all that you have to understand basically on function pointers. So now I'm just going to hop into an example whereby I show you how do we use function pointers, how do you declare function pointers, and all that stuff. So just take out my pen from here, and then I'll go to this section. So can you see?
Can see. Yeah, we can see.
All right, so I divided this into two parts. So I'll have the part whereby I demonstrate the use of function pointers in general and also the use of function pointers for your printf project so that you guys can understand what's happening. So I'm just gonna change directly to the part whereby I'm gonna be demonstrating the use of these function pointers. How do you declare them? How do you create them? And all those things. So in here, currently there is nothing. So I'm in a situation whereby say I want to use a function pointer, okay, or just make use of the concept of function pointers. So you know that say you want to do addition, subtraction, or division based on the arguments that you pass or the command line arguments. So one way you could do that is maybe do this. So say your program name is called test, and you say test, you want to add 1 plus 2. So I'm just gonna do this. So say you want to do something like this. So this is your program that you've compiled and you've created, and then now these are the arguments also that you're passing into your program. So in a situation that is similar to this, you have two operands in this case. You're using 1 and 2, and then you also have a condition which is your addition. So it makes sense if I wanted to divide those things, or if I wanted to multiply them, I would use a certain arrangement in such a way that based on a certain condition, this is the operation that I'm going to perform. So this is not different from the task that you did on function pointers. I don't know if you still remember that, but it's a similar concept. So what I'm saying is this. So if I define my main function, which is .c, so now in this case, I'm just going to include my main.h. At this point, I didn't create main.h, but don't worry, I'm going to create that now. So I don't have time for these things because I'm limited to 1 hour. So what I'm going to do, I'm going to say this is my function main. It takes in, in fact, takes in an argc. It takes in also argb, which is an array of arguments that are passed by the command line. So this will always return 0. So now this is what I'm saying. We have a condition and we want to execute based on a certain condition. So I've just created this dumb main function which doesn't do anything at this point. Or else happening in this case, I'm going to do this, right? So I'm just going to create the main.h that I just included in my main function. And then from there, I'm going to define this. So if not define main h, I'm going to define it like this. And then I'm going to end it like that. So this is your main header file. So now here I will include the libraries that I'm going to use. So stdio, that one I'm definitely going to use. Also, maybe I need to include the standard library .h. So say I want to include those things for now. So this is what I'm going to save as my main.h header file for now at this point. So like I did previously, let's say if I have a program like that and then I take in 2 arguments. So in this case, I'm going to use those arguments. So in using those arguments, what I'm going to do is this. Because I want to use the concept of function pointers and I want to execute based on a certain condition. So my condition will be either this, it's either a plus, a minus for negative, the backslash for division, or the forward slash for division, and also the other operators which you might use. So that's what I'm going to do in this case. So in this case, I'm going to create, in fact, I'm going to open the main.h header file, but I'm going to create a new data structure. So in creating that structure, you know that when you create a structure, you just say struct, and then you can just call it anyhow you like it. So I'm just going to say this is node. And then from there, this is what I'm going to do. So I'm going to take in a char, which is my C, which will be based on the condition of operation. In this case, it can be a plus, it can be a minus, it can be anything. And also, I want to have an integer, okay, being returned from a function pointer. So this is going to be my function pointer, and I'm going to call it a func. So it takes in 2 integers. So it's integer 1 and also integer 2 in this case. And I'm just going to create this or name this in a different way. So I'm just going to go with no name at this point because I don't have any name that I can give it to. But in essence, the reason why I'm creating this data set is that I'm going to store a condition and also a function based on that condition. So I'm making use of the concept of function pointer. So what's happening here is that I've got a function which is called f, it's func. It takes in 2 integers, but it's a function pointer. It's not like when you're declaring a function. So if I did this or something like this, what could have happened is that this is a function declaration. It's like I'm declaring a function called func that takes in 2 integers and returns a pointer to an integer. So in order to avoid this and return a function pointer, or make use of the concept of function pointers, I'm just going to wrap the asterisk and also the name of the function under these braces to make a function pointer. I hope that makes sense for everybody. Are you still fine with what I'm saying? Just confirm yes, no. If maybe someone is lost so that I can repeat what I'm saying. Are you
I
guys?
think we're still good.
Okay. So I created my data structure like that, and I want to do a certain operations based on those things. So what I'm going to do, I'm going to create a main, in fact, open my main function. In this case, I want to do that. Remember, I had a data structure that I created. It's called non-name in this case. So non-name will be, let's say, my array for now. So it's an array, and then this array will contain, say, the function and also the condition based on that function. So you'd have something like this. If I wanted to have maybe let's say 4 function or 3 function, what I have is this. Based on the structure that I created, I need to have a char and also a function pointer. So if I wanted to do addition, I'm just going to use plus, and then what to follow is a function called addition. At this point, there is no function called addition, but I'm just going to create that now in no time. Also, let's say now you want to do maybe subtraction. You have a char maybe that's denoted by a dash for subtraction, and then you will have your function maybe that you've created called subtraction like that. So the same thing for division, you will have a char for a forward slash, and then in this case for division, I'm just going to call it div like that. So I haven't created those functions. What I'm going to do is this. So I'm going to create a file which contains all my functions. And then in this case, what I'm going to do is this. So I'm going to create a function that returns an integer. It's called addition. So it takes in integer x and also integer y, something like that. Then the only thing which I want to return for addition is just going to return x plus y. So I don't have time for documenting these things because of time constraints. So the same thing that we do for a function that would do subtraction, we just have a function called subtraction. It takes in an integer x and also an integer y. What it does is that it returns the subtraction of those two arguments. So maybe say x minus y. So you do something like that. So same thing for division, it's integer, and then it takes in an integer x, integer y like that. And then what you will return in this case is this. You will return maybe let's say x divided by y. So that's what you would do based on your function. So now I've just created 3 functions which do simple operations, and I've saved them in a file called functions. So all of them are fine like that. So what I'm going to do now, I'm going to open my main.h header file and also define the prototype for those. So I've got a function called addition. Addition takes in an integer x and also integer y. And in that case, it also returns an integer. I also have a function called subtraction that does almost the same, but not really the same. So it's x is my first parameter for that function, and also y. So this is the prototype for the subtraction function, and also define the prototype for the division function. So you've got an integer x passed in, and also your y in that case. So these are my function prototypes which are created like that. So now I'm gonna hop in back to my main.c file and also do some operations. So this is what I've done. I have a data structure that I've created. That data structure contains 2 things. It contains a condition and it contains an operation based on a condition. In that case, a function pointer. Okay. So if I named my data type no name in this case, and I say no name is an array. Okay. So it's going to be an array which contains the condition and also the function pointer. So the first condition, it can be addition. Okay, so it's plus for addition. The second condition is minus for subtraction. The third condition is the forward slash for division. So those are the conditions which we have based on that. So what I will do is this. So I'm gonna have say I have I as my iterator. So I've just defined the data type for I then, and then this is what I'm gonna do. I'm gonna set maybe let's say I'm gonna look through the arguments there and also match them if they're the same with these ones. All right. So before even looping, I need to also have those arguments. So because now if I wanted to do a setup operation, like I said before, you'd have something like test, and then test would be maybe 1 plus 2. So I'll have the first argument as the program name, the second argument is the first maybe operand of the operation, and then the third one would be the condition. In this case, it can be plus or whatever the operator is. So I need to have those. So let me just come in here before I even look through my array to match them to see if they're the same. So I'm gonna have this. So I'm gonna have, I don't care about the argument name in this case, or the program name, because that's the first argument. I care about the second and also the third one, and also the first. So first, not the 0 1. First as in 1. So I care about the argument in position 1 and also in position 3 and also in position number 2, except for position 0 because that's the program name. So what I'm gonna do is this. I'm gonna create say 2 integers also. Maybe I'm gonna call them x, and also I'm gonna call them y in this case. And I can have let's say an operation. So this will be an operation for operation like that. What I will have here, I will have this. So I'll have my operation will be equivalent to my argument v, which is on the 0 1 2. It's on the second um it's on the second index in this case, but in the 0th position. That would be my operation. Then I'll have my x, in this case the first um input argument to the operation, which will be let's do this. So it's gonna be my arg v. This will be in the first position, it will not change, but I'm gonna change this to a number. So I will use arg to do that. So I'll also do the same for my y. So for your y, you will have your atoy, and then in this case, it's gonna be your arg v in your third position. Those are my operands that I'm going to use for the operations. So what I want to do, like I said, I want to look through each and everything that's in here and make sure that I match this operation or this condition to operation, and also return the function pointer based on that. So what I'm going to do is this. So I'm going to say my I is equivalent to 0. I don't care about the condition, but I'm going to keep on increasing the I like that. So what I will do in this case, I will do this. I will simply say, if ever you find that your operation is equivalent to my array, so I can hear that there is something, but I can't see it on like behind the scenes. Is there someone wants to say something?
No, I wanted to ask a question.
Yeah.
I think I was lost a bit. Why is the operation when you kind of access using the double
Oh,
index?
okay.
So yeah.
All right. So you're gonna get the operation as a string like this, right? Because everything that comes from your command line, or let me just do this. What argv stores, it's strings. Everything inside argv will be a string, right? And a string, you know that is in double quotations, right?
Yes.
So from
I understand.
there, you don't want to be comparing a string to a char, because what I have, these are characters, right? So for me to capture the operation, what I would do is that I would simply index into the argument that carries the operation. In this case, it's going to be 0, 1, 2, right? That's
Okay.
why we have these two. And then in that 0, 1, 2, if I had something like plus in this case, then I would know that these will always be in the 0th position. It will not change.
Okay.
So are you fine with that?
Yeah.
So you would have something like that. So in this case, I'm looking through my array that I've created, which contains a condition and also the function pointer based on that condition. So you want to check if your operation, the one that we've just received from your command line, is the same as maybe one of these conditions. So you would do this. If your operation All right, it's the same as my array. If now your I is equivalent to 0, it's going to go to the 0th index of your array, which will be these two things, okay? It's a condition, which is your plus in this case, and also the function pointer. So that's what we'll have. So if that dot c, because remember how we've defined our data structure, no name in that case. So if I just hop back into that one, we'll just say main.hash will be this. So you'll have a char like this, and also you'll have a function pointer, which is denoted as fun. So that's what I'm talking about. So if you go back in this case, you want to check if your operation is the same as your array at your index. So at your index, it can be, it's gonna be this or this or this. Okay, so dot C will just give you this or this or that. So these are the things that you might have. So if the thing at that case is equivalent to that, what you want to do, you want to return the whole thing, okay? Or maybe you want to do something like this. You want to return your array at that very same index, but now you don't want to return the array alone. You want to return the function pointer, but you know that this thing, it takes in two things. It takes in your x and it also takes in your y. So these are the things that you might want to do, because even your function pointers, what they do is that they will return an integer to the operation, okay, because of what function they're pointing to. So it's the same with this one. Are you fine with this? Let me check. Is everybody fine with what I'm saying? Can you hear me?
Yes,
I
you
didn't
are
want to
being.
ask. Okay.
Oh, okay.
Yeah,
No, thanks.
that's good.
So it's either you do this, like I was saying, or you can just do this, because this will just do the operation. So from there, maybe you want to store it somewhere. Let's just say create a variable which is called store. From this variable, what you will do is simply say your store is equivalent to that. All right. So that's what you would do in that case. And then because you would have found your operation, you need to break out of this loop. So what you do is that you break. Okay. So from here, you might want to see the operation that you have performed. So this will be percent %d new line, because that's an integer. So you want to print your store like that. So hopefully everything makes sense. So let's just do this. So I want to compile my main.c, and then there is functions which contains every function that I'm using. And then let's just say this is your test like that. Okay, so let's see. Conflicting types for div have int that is div. Okay, so that's happening. So let me just use a different name for this thing. So it's gonna be vim main.h like that, because it doesn't matter, it's still the same thing. It will be vim, and then these are your functions. So let's see. So let's see if I'm still getting the same thing. So initialization of an integer from incompatible type attribute div. Okay, so vim main.c like this. And since I'm not using this, I'm just gonna do that. So save it. Let's see. So now if I pass in test and then say 1 plus 5, you get 6. And then if I do this, let's say for subtraction, 1 minus 1, get 0. And then let's say you perform division. Okay, maybe you want to take 10 and then 10 divided by 2. So that will give you 5. So are you guys happy with function pointers at this point and how you would use them based on a certain condition? So can you hear me?
Yes, we understood.
Okay, so now we have to take the operation of function pointers or the whole concept and take it to how we might use that based on our main printf. So since I had two things in this case, the one for the demonstration of how you use function pointers and also the one whereby you'd use it in your printf. So let's just jump into the printf function, into the printf folder in this case. In here I have this. Okay, so if I simply bin inside my printf, this is what I have already. Okay, so the last time you executed something, okay, you made use of switch cases whereby if maybe the character was equals to C or D or S for string, then you would do a certain operation based on that. So you want to use the same concept, but now there are so many things which are happening with your printf. So it's not only going to be C, D, and I. There are so many things. So if you write everything all on one function, so it's going to be a very, 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 very long function. So you can also make use of function pointers in that case to reduce your function and also do operations based on also the condition. So the concept won't change. It's going to be condition execution like that. Are you still happy? Yes, no?
Yes.
Okay. So I can't see the other thing. So you have to talk so that I can see or I can know that what I'm doing is wrong, what I'm doing is on point.
Just continue. But then whenever they have a question, they can unmute and cause.
Oh, okay. So like what I'm saying is the last time you had something like this, okay, so you made use of switch cases in this instance, saying that maybe if you want to check your format, at that ith position, maybe you pass it inside your switch case, and then from there it's going to check case by case, and then you execute. So now when you're making use of function pointers, maybe you want to do this thing different. So this is not much different from the function that you created the last time. It's just that I did some few manipulations based on that. So when you have format from your printer, from your original printf, format will be a character receive, maybe let's say characters within a string. So long as you have not hit the percent, what you do is that you print everything. But the moment you hit percent, then something happens. You want to check everything after the percent. So you will check maybe the character after, if it's D, if it's C, if it's what. So it's the same thing. So now what I did something like this. So I have my two functions. Say if I open up this functions file, so I have this. So I have a first function which is called putcha, and then the second one is called put. So these functions, they are responsible for printing out a character and also a string. So if I wanted to print out a character, usually would have something like this. You would have something like this is not really necessary, but I would have a chassis and then just print out the character of my choice. The same thing would happen with my put. So put will not have something like this, would have something like uh maybe this will be a char pointer, which is your string. So print a string based on that. But the way we used our function pointers in this case is that if I cd from here to go to function pointers and then check out the main header file, you would see this. I had a condition and also I had a function pointer that points to a function that returns an integer. But the function took in an integer and also an integer. So in that case, all of those functions, they had the same input arguments, an integer and an integer. So what happens in the case whereby you don't know the input type? So it can be an integer, like when you are using char or put char, you know that the input into that should be your character. When you have something, maybe a string, something like that. So you can't point to functions in that case which point or which take in arguments of different types. So they have to take in the arguments with the same type. So for you to avoid having a situation whereby maybe you have a conflict of input arguments type in that case, you might do something like this. So in here, let's see the files which I have. So I'm just gonna hop into my functions. So you vim your functions, okay, and then from there you have these two functions. So if I check correctly, my format from my printf, from the original prototype of your printf, it has a string with multiple characters. So what you did in your main thing is that you printed before you even reach the percent sign. So now these functions are no longer how can I put it? The put char, if I want to point to it, and also the puts, they carry different input types. So now if I do something like this and say, what if I take in, say maybe a character ch as my input type in this case, and then also what if I take in something like the VA list, okay, which is my AP in this case. So from this, I'll know that if I match maybe let's say a character within this putchar function and I map it to be the same as maybe same, then I would know that from this I need to extract whatsoever character that's within my list and also print it out to the standard output. But if also there is no such thing, then I can print a normal character in this case without even doing much. Am I clear in that case? Okay. So the same thing that I'm gonna do is that okay for this puts function. So I will take in also the char and also the VA list in this case. So both of these functions, they return what? Integers, both of them. So what I'm gonna do is this, all right? So in your put char, so let me start with this puts. Okay, so in my puts, I'm gonna declare an integer in this case, and then from there I'm gonna do this because I need to print out based on a condition. So what I'm gonna do is this. I'm gonna check if the input that I'm passing is the same as my S, like that. So if that is the condition, what I might want to do in this case, I might want to do this. So you're gonna do something like this, say you have an integer which is I, we're starting at 0, and then from there you wanna look through each and everything that contains a string within your VA list in this case, which contains like all the things that we passed in with your printer. So you want to do this, okay, and you want to also maybe do something like this. I have a string that you've declared. So I know that from my list that I've passed in as my input argument, I'm gonna have a string in that case, which I'm gonna have, okay, and then this will be a char pointer from your variable arguments inside your AP, which is your VA list. So that's what I'm gonna have my string. So you might want to do this. While your string fi has not reached the null character. So while you have something like that, what you might want to do, you want to print out each and every single character. So you might wanna use let's say your butcher, all right, in that case. So in this case, I'm not gonna use butcher. So you might have to, or you might wanna use something like write. So I wanna write out to my standard output, which is the value of 1, and then from there, this will be the address of my string at I because of how the function is defined, the right function. But since I'm printing character by character, so I'm gonna pass in 1 also in that case. So you wanna do this and you wanna also increase your I. So I is equals to I plus 1. So that's what you wanna do based on that. And then from there, maybe let's say you return your I. Are we still together?
Yes.
All right. So I'm gonna do this and also check out my files. So if I go to my normal printf like that, what I have here is this. I'm looping through each and everything and I'm saying so long as I've not reached the percent sign, what I want to do is that I wanna do something. And what you are doing, you're checking if that thing has not reached the null byte before you even do something. Because if you reach a null byte and you don't do anything, it can return a garbage bin. So that has been taken care of. So what you want to do in this case, you want to come back to this. You want to have a function that will take in also that format and also the what the list of your arguments that you passed in along with your printf. In that case, what you want to do is that you want to execute based on the conditions which are there. It's the same thing that we've been doing with function pointers. So if I vim my batch that I've just created, batch now contains nothing. But what you want to do inside the batch, you want to do something like this. So remember, it's almost the same as how your functions are defined. So in this case, you have your character, and also you have your list which contains the arguments which come along with the character in that case. So what you want to do, you want to do something like this. So because you need a condition and also you need a function to take in along with. So you will do this. If I open into my main.h, my main.h contains this thing. So in my main.h, I've created a structure which is called func in this case. Func takes in fact, has two things. It has a C as my character and also the function called pointer called FP. And it takes in the char and also the AP list. So what I will do is that I'll just go back to my batch again, and what I will do something like this. So I will use the data type called func in this case, and then from there, what I will do is that same thing. I will have my array. Okay, so when you're declaring an array, you do something like that, and then curly braces. So you wanna have something like this also. So what would happen if ever my character is C? I need to have a function that will print that C. In this case, you can use maybe a function of your choice. In this case, we have a function called butcher. Now, if my character say is S, because I have two functions for my C and also for my S. Now, if my function is equivalent to S, then I can also use put in space for S. All right. So what you will do in this case, you will have your array containing these two things like that. So you will match if your C or whatever condition inside your array, because now if you say array at 1, you will have two things. So you'll have your condition and also the function, condition and the function. So what you'll do is that you'll compare this if this is the same as either one of these, maybe C or your S. And if that's the case, then you do the operation based on the condition. So in this case, if your CH is equivalent to your C, then what you will do is that you will print using butcher. And then if ever now your CH is equivalent to your S, what you do is that you put S like that. So this is not like how you're gonna go about your function when you're creating your printf. I'm just showing you how you might wanna go about it in this case using function pointers. So now from what you have your array containing the conditions and all those things. So because I want to look through my array, I'm going to create an integer I like that. And then this is what I'm going to do. I'm just going to initialize I to a value of 1. I don't care about the condition much at this point. And this is what I'm going to do. Because you will check if your array at whatsoever position, because now you're checking .c. When I check if that thing is the same as your ch. Now, if you find that that's the same, then what you want to do, you want to return your array dot, in fact, your array at I dot in this case. So what you will have there is that because you created your function and inside your data type that you created, you have your character and a function point. The function pointer was called fp. So in fp we pass in two things. You will pass in your ch in that case, and also you will pass in your AP. All right, so you'll pass in the connection and also the AP like that. And from there, what you might want to do is that you might want to return your I, just for demonstration purposes. So what you're doing is that case you're checking if this is the same as this, and if that's the case, you execute based on that condition. So if it's put char like that, you execute based on put char. If it's s like that, you execute based on your s there. So that's what I'm actually doing in this case. So are you fine with what I'm saying? Okay. So if I go to my main printf, okay, the one that I created, I have this, all right. So last time we were using the switch for doing the same thing. So in this case, you will do something like this. You'll have a function, because you already have a function that's called batch. Batch takes in your char. So this will be like your format at position I. And then from there, you'll also pass in your VA list. In this case, it's going to be your AP based on how it was defined on that one. So what this will do is that it will do the printing based on that condition. So if you're printing your I, it's just going to print I based on the condition. So same thing as that one. So now let me define the put char function. So if you open your functions like this, inside your functions, you will only have maybe a function for puts. Puts, what it will do is just going to print based on that condition. So now in this case, what you might want to do is this. In a put char, let's say we have an integer called j, something like that. And initial, I'm going to take in, maybe let's say this j is equivalent to my character. In fact, let me make it a character, not an integer. That will cast the results. So from here, what I will do something like this. If ever my ch is equivalent to my c, like that, what I will do is this. I will take my j, and then from there, I'll assign it to the argument in this case. So I'm going to take in the AP, and then this will be like an integer. So in characters are integers basically. So we'll pass in that integer there based on that j. So from there, what you'll have is that you'll have your j being equal to something. So what you would want to do in this case, you might want to return the right function, the output of the right function. But from here, I just have one. So I'm printing out to the standard output. So the thing that I'm going to print in this case, I'm going to print the address of j. In fact, it's not going to be the address, but the variable that contains the character is the reference like from that. And then from there, you will have one because it's just only one character. So you might want to do it like that, for example. In this case, I have my function, which is my put char that print out something. And also I have my function, which is also called puts, that print out something, string in this case. So if you go back to your printf function again, so in this case, we have same connection. Nothing has changed much based on this. So from here, you're just passing in format and then the AP inside your batch. So that's fine like that. So let me see something. So inside my main.h, I also have, I do have all these functions like that. So hopefully everything runs okay. So I'm just gonna compile this. So I want to compile my printf along with my main.c, and I also have functions plus batch. So my results will be, let's say I do something based on print. Okay, so let me go and fix that. So this will be inside my batch. The problem is here. So if we do something like, for example, print, okay, there is a problem. So let's check. So inside my print, what I'm doing is I'm looping through each and everything inside your format, which comes from your main print. And then so long as I've not hit my null character, I'm going to keep continuing and continuing and continuing. So in this case, I'm printing out my character from here. Let's see. You are printing out your character one by one, and then you return your I, and then also you do the same thing. So the things which I changed much in this case, it's just gonna be, so let's check. Let's see inside my functions. So here, if I put condition equivalent to S, what I will have is that I'll print a string. So I'm gonna extract that string on my variable arguments, the list which is given as AP. And then from there, let's see. So long as I've not reached the null byte, what I want to do is that I want to write out something, okay, based on that. You want to write the string which is add I, and I don't think there's a problem with this one. Let's see. So in this case, I'm doing the same thing, but I'm taking also the address of this one without any hassle. So I don't see anything different from this. What's causing segmentation fault? If you happen to see the problem before I do, you are free to speak. See.
I actually can't see your screen, but I'm watching from YouTube. So there's a little delay.
All right. I'm saying if someone can see the problem before I see it, you are more than welcome to speak.
Can you hear me?
Yes, I can hear you. Are you saying something?
I don't think he's.
I wanted to point out something, but I saw it was written correctly.
All right. So I'm just checking out what might be the difference. So let's see. Let me use put in here instead of using this. I want to see something. So your string I and then AP. I want to see that. Okay, so maybe you might want to do something like this. Check. Let's do this. Sure. As I'm printing out the string, and eventually maybe a new line would be place to start. So something like that. Okay. I still get the same problem, so it's vi. Okay, let me do this. So I'm gonna check what is causing, where this might be coming from. Right, so for some reason I can't see where the segmentation fault might be or what's causing it in this case. Let me check. Let's see here. Let's see.
Spamandla. Sorry, can you hear me?
I can hear you.
No, I was just wanted to ask because you kept on talking about the previous example you had, like a session you had. Is there any way can I watch a recording of that session?
Oh yeah, I think it was recorded by Martin. So Martins must have the link to the session whereby he did
I'm
it.
going to post the link on the chats now.
Sorry?
I'm going to post the link on the chats now.
Okay, thanks. Please do. Thanks.
Is anybody recording this one too? Because I came late.
Yes, this one is being recorded.
Okay, please. After the whole thing, I would like to watch it from beginning to the end. Because I have a
Alright,
lot of questions that I have not gotten answer yet. Maybe the answers are in the video.
no problem. The recording will be
Thank you very
on.
much.
So I'm trying to check where the segmentation fault might be coming from because from what I'm seeing, I don't think there's something I did with code that's wrong, but memory manipulation there is a problem somehow somewhere. I'm trying to trace it and then I don't see where the problem might be at this point. I don't know if anyone can see that or because we're out of time or what. Or see if I can also record another session, post it back whereby I've detected the problem and everybody can see what went wrong. Or maybe we can continue from there.
I
Especially, I
think
don't know.
that also works.
So from
Maybe
there, you're
you
saying that
record. I can hear myself from the lesson. Oh, maybe it's this YouTube. Sorry.
okay, for people who attend, I will record a session explaining the problem, where the problem might be, and then from there we'll move forward. Because now I can't seem to find where the segmentation fault is, or what's causing the segmentation fault in this case.
Yes, if you record the session, we can have a link to the session as well.
Yeah, that's not a problem. So I think that will be all based on today's session. I don't know if anyone has questions, except for the fact that I will record the session again.
Conda would like to speak. If you Conda, you can go on. If you're raising your hand.
I'm saying that was a mistake. I don't have anything to say. Sorry.
Okay. Okay, please, guys. We're going to do another recording, but the mistake will be corrected, or we'll find the segmentation where the segmentation fault is coming from, and we'll make that video available as well.
Okay, like before everybody leaves, they have to just spell out something. So before anyone can leave, just please do not leave at this point. So I want to find that thing.